Hey guys, it's Mrs. Chef Check again. This video is on box and whisker plots, and the focus is how to interpret them or how to read them. If you're looking for help with constructing them or making them, go back onto the links and you'll find one for how to do that. This one's strictly on how to make sense of the data and how to interpret it. Make sure you have your notebook and your pen or pencil ready so that you can take some detailed notes, because you can use them on all your tests and quizzes. The first thing we need to do is, if you didn't already add a title to your notes, go ahead and do that. These are box plots. Okay, so when you look back, you'll know what it is that you're looking at. The second thing I want you to do is draw out a rectangle. Okay, we're going to make a generic box plot here. Off to the left, we're going to put our whisker with the data point. And off to the right, we'll put our whisker. All right, and then somewhere down the middle, doesn't have to be, it could go here, it could go here, it could go here, it could go here. You can decide. Draw a line down the center. Okay, this is our generic one. This is where we're going to kind of label where things show up on a box plot and what it shows. Now, one thing that's important to know is that, well, think about this. This point over here is our minimum value. Okay, that's our lowest number in our data. And it also has a second name, which is important that you write down because it can get confusing if you're asked this and you don't know what it's asking you. This is also called your lower extreme. Okay, it's the lowest number in your data point. Okay, and then if you go way over to the right-hand side, we've got your maximum. Oops, you know what? That's not going to fit. Sorry, let's try this again. You've got your maximum, which goes by another name. Could you guess what it is? The other one was our lower extreme. This is our upper extreme. Okay, so make sure you have both of those recorded for each of those points. All right, the next thing that we can look at on our box plot is this line in the middle of our rectangle. This represents our median. And remember that median is the middle value in all of your data. Okay, so half of our data falls to the left of it, half of our data falls to the right of it. It splits everything right in half. Okay, if we, excuse me, if we go over to the left side of our rectangle, right here, this is another point that's important, and it's called our quartile 1, or our first, oopsies, whoa, our first quartile. Let me get this squeezed in here. First quartile, or just Q1. Okay, it also goes by another name. I know this sounds confusing here. It's got another name that's important to know. This is called our lower quartile. Again, have both of those terms recorded because you'll need to be familiar with both of them. And then if you look over here to the right-hand side of our box, you will see this is our third quartile, also called Q3, also called our upper quartile. All right. Again, it can sometimes get confusing when you're looking at lower extremes and lower quartiles, and then the upper extreme and the upper quartile. So make sure you're familiar with each of them, and just remember, extremes are the ones that are really far out. They're extremely far out. The quartile splits up kind of our quarters, our fourths. All right. Now, you might be wondering, why do we have a Q1 and a Q3? Whatever happened to Q2? Well, our second quartile is also the same thing as our median, but we usually just refer to it as the median. Okay, so you might also be thinking, like, where did these names come from? Why are they called quartiles? Well, if you think about this prefix in the word quartile, think about how many quarters are in a dollar. 4. How many babies would quadruplets be? That would be 4. A quadrilateral has 4 sides. This is referring to something with fourths. we took our data point and split them up into fourths. And now this is what's really neat about box plots. This piece represents a fourth, this piece represents a fourth, this represents a fourth, and this represents a fourth. Okay, so the way we show that usually is with our percentages. So there's 25% of our data, there's 25% of our data, there's 25% of our data, and there's 25% of our data. Okay, so at any given point I can tell you where, say, the middle 50% of the data fell. It would be in these two middle quartiles because there's 25 and there's 25. Or I could talk about 75% of our data. The numbers between here and here would be 75% because we've got 1, 2, 3 quartiles, and each quartile will always, always, always be 25%. Alright, so before we go on to an example, just one more time, let's look at this. We've got one quartile. This represents our first quartile, right? This is our second quartile. This is our third, and this is our fourth. Okay, we don't label this as our fourth, we just call that the maximum. Sometimes people think there's just the 3 quartiles because that's all that we really see labeled here, but remember we're talking about this range of numbers in between each. So we've got 4 intervals, we've got 4 quartiles here. Alright, let's take a look at our first example. This box plot shows the annual clothing budget. It asks, what is the median clothing budget? Well, I know now that the median is that middle line on my box plot that splits my data in half. So my median is $1,500. Okay. My upper extreme, again, notice it's the upper extreme and not the upper quartile. So it's the one that's extremely far out there. That's my upper extreme. Looks like that's about $2,300. Okay, let's just call this A, B, C, and D for sake of writing out the answers here. So my upper extreme is $2,300. My upper quartile, which is also, again, the third quartile, which is the right-hand corner of my box, that is $1,800. And for D, it says, why is the whisker from 1,800 to 2,400 the longest? Well, that's a really good question. That's something that sometimes confuses people. I'll tell you what the misconception is. A lot of people think that the longer the whisker, the more numbers that fall in there. But we know that can't be true, right? Because remember, every box plot is broken into fourths. So there's no more numbers in that quartile than there are any other quartiles. Okay, but the reason that it's so long is because that quarter of the data, or that 25% of our data, is really spread out. So there's more of a range in the answers, or more of a range in the numbers in that particular quartile. Okay, so it's the longest because, sorry, I'm going to take some time here to write this out, because the data is more spread out. You'll be asked that quite a bit. That's part of interpreting box plots, is why is that whisker longest? It's because the data is more spread out. There's more of a range in the numbers. Alright, let's take a look at example 2. You'll notice this one's different because we have 2 box plots, right? We've got a double box and whisker plot. The reason we're doing this is so that we can compare different things. We're going to compare your class's test scores to your friend's class's test scores. Okay, and this question is asking us which statement is true about the double box and whisker plot. Okay, so let's go question by question and see which one we know to be true. So for letter A, it says 50% of the scores in your class were below 85%. Well, 50% below 85. Well, if 50% means I'm looking for my median, right? Because that splits my data in half. And I see that the median in your class, so this top one, right? Make sure we're looking at the right one. There's my median. Nope, that's not below 85%. It looks like 50% are below 90%. Okay, but that's not what I was asking. So A is not true. because 50% of our scores are below 90%, not below 85. And you could actually correct that if you wanted to. Actually, I won't because I don't want to mess people up. If we look at letter B, it says the median of your class was 95%. Well, we actually just figured out the median of our class again, right here, and we said it was 90%. So B is not true. The lowest score in your friend's class was 60%. I see lowest score and I think to myself, I'm looking for the minimum value or the lower extreme. So I'm going to hunt to my friend's class. Again, make sure we're looking at the right one. And I see, ooh, my minimum is 60%. So this one appears to be true. But it's always a good strategy to keep going and make sure the last one is not true before you make your final answer. So let's read D. It says, your class has a larger range than your friend's class. Well, remember, your box plot shows you the range. And so if we look at our range, which is from here to here, and your friend's class's range, which is from 60 all the way up to 100, so their range is 40, your range is only about like 32, their range is bigger. So D is not true. Your class does not have a larger range than your friends. So we've confirmed that C was our correct answer. Our third example says, the box and whisker plots show the minutes it took for the members of 2 cross-country teams to run 3 miles. And we're asked, which of these is false? Okay, so we're not looking for the true one this time. We're looking for the one that's not true. So let's just kind of go letter by letter and see. It says, the medians are the same for both teams. Well, I'm going to go back and look at Team A. Their median is 25. And Team B's median, also 25. So letter A looks like it's going to be true for us. So we know that's not going to be it. B says, Team B had the fastest runner. Now, I know that when it comes to running, the shorter the time it takes you, the faster you are, right? So even though your tendency is to look for the biggest number, keep in mind we're talking about running. So the fastest runner is the person who has the smallest time. And so I looked for which minimum is lower. So Team A's fastest person ran it in 20 minutes. So it took them 20 minutes to run 3 miles. But Team B took their fastest person only 13 minutes to run 3 miles. So it looks like Team B was actually the faster runner. So this one's also true. We're going to rule that one out. Let's look back up now, and it says 75% of the data for Team B is above 25 minutes. 75%. Well, that's 3 quartiles. So let's look for 25 on Team B. And I see right here is my 25. And I've only got 1, 2 quartiles above. There's only 50% that's above 25 minutes. C's looking like the false one here. But let's again go on to D just to make sure that D is true before we decide on our final answer. D says Team A had the slowest runner. Well, again, this is similar to B in that when we're talking about the slowest runner, that's the person who took the most time to finish the 3 miles. And so it looks like Team A's slowest runner was 40 minutes and Team B's was only 32. So it's true that Team A had the slowest runner, therefore confirming that C was correct. 75% of the data for Team B is above 25 minutes. That is false. Here's the final example, I promise. Last one. It says, look at the box and whisker plot on the right, which is true. I'd like you to actually try this one by yourself and see if you can come up with the correct answer, and then come back and play the video to see if you were right. All right, do you have your answer selected? Let's see if you were correct. It says the median is 27. Well, I look here at the middle of my box and I see, nope, my median is 20. So, A, not true. For B, 75% of the data is between 17 and 32. Well, here's 17. Here's 32. And again, if I like to count quartiles, I see 25, 50, 75%. Looks like we may have found our answer here. Letter C says the lower quartile is 7. And I am not going to be fooled by that because I know that this is not my lower quartile, that's my lower extreme. So that is not true. Our lower quartile is actually 17. We can rule that one out. And for D, most of the data is between 7 and 17. And again, I know better than that because I know that just because the whisker's longer doesn't mean there's more data there, right? It just means it's more spread out. So no, there's not more data between 7 and 17. We can rule that one out, confirming that letter B was the correct choice here. That 75% of the data is between 17 and 32. So how'd you do on it? Did you get it right? Do you think you're ready for some more? Let me know if you have questions on these, and I will see you in class. Thanks for watching.